The method of completing the square to solve a quadratic equation can always be used to solve any quadratic equation. If we start with the general quadratic equation, x squared plus bx plus cx equals 0, or a is not equal 0, and complete the square to solve this equation for x in terms of the constants a, b, and c, the result is a general formula for solving any quadratic equation. We're going to use that a is greater than 0, or a is, and I'll just quickly go through the process of completing the square. First, of course, we need a 1x squared, so we'll divide by a. X squared will plus b over a times x, plus, we'll leave room for completing the square, equals, we've moved the c, so negative c over a plus, they're completing the square. X, half of b over a is b over 2a squared. B over 2a squared is b squared plus 4a squared. So we add that to both sides. Now, combining the like terms over here, 4a squared becomes my common denominator. I'll put the positive b squared first. And the negative c, we'll have to take it times 4a to make this 4a squared. So my minus 4ac. Now we need to take the square root of both sides. So x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 4a squared. Well, the 4a squared is a perfect square, so we can just take that out as 2a, and we'll have plus or minus the square root of b squared minus 4ac, and this is we need to move the b over 2a to get x equals, it'll become negative b over 2a, and combining that into one fraction, we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This becomes a formula we can use to solve any quadratic equation. So the quadratic formula, the solutions to the quadratic equation ax squared plus bx plus c, where a is not equal 0, or x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Do make sure you remember the fact that it's all over 2a. To solve this problem, first we have to get it in standard form. So we'll have x squared plus 6x minus 3 equals 0. In this case, a equals 1, b equals 6, and c equals negative 3. So x will equal negative b, so negative 6, plus or minus the square root of b squared would be 36, minus 4 times a times c, which is my negative 3. All over 2a, so 2 times 1 will be 2. Be negative 6 plus or minus the square root, negative 4 times 1 times negative 3 of 12, 38, 36 plus 12 will be 48, divided by 2. X will equal negative 6 plus or minus 4 square roots of 3, since 48 is 16 times 3, all over 2. Since 6, 4, and 2 are all even numbers, I can reduce this and make it negative 3 plus or minus 2 square roots of 3. Another problem to try, we'll get it in standard form. 4x squared minus 3x plus 5 equals 0. A equals 4, B equals -3, and C equals 5. So x equals -b, that will make it a +3, plus or minus the square root of b squared. -3 squared is 9, minus 4 times a times c. A times c would be 20, all over 2a. 2 times 4 is 8. X will equal 3 plus or minus the square root of -71 over 8, or x will equal 3 plus or minus I times the square root of 71 over 8. I want to solve for the specified variable using plus or minus when taking square roots. So we're solving for r squared. The first thing I'm going to do is multiply by 3. So I'll end up with 3v equals pi r squared h. That means r squared is going to equal 3v divided by pi h. Taking the square root of both sides, I'll find out that r equals plus or minus the square root of 3v over pi h. I will need to rationalize the denominator, so I'm going to take pi h, the square root of pi h times each the numerator and the denominator. R will equal plus or minus the square root of 3v pi h all over pi h. Again, we're going to solve for the specified variable. In this case, the diameter here. So first thing I'm going to do is multiply by 4. 4a equals pi d squared. So d squared will equal 4a divided by pi, taking the square root of both sides, plus or minus the square root of 4a over pi, be plus or minus 2 square root of a over square root of pi. I'll need to rationalize that denominator by multiplying by the square root of pi, and I'll find out that d equals plus or minus 2 times the square root of a pi all over pi.